Alright, in this video I'm working with problems from homework 12.3, and this is the homework that's focusing mostly on interval of convergence for Taylor series, but also mixing in, all the other stuff that we know about Taylor series up to this point, which really is everything except for the Lagrange error bound. Okay, so we're going to start off with, this one was from 2016. The function f has a Taylor series around x equals 1 that converges to f for all x in the interval of convergence, which means that we're probably going to have to find that interval of convergence. It is known that f of 1 is 1, f prime of 1 is negative half, and the nth derivative is given by this formula that we could just plug in the fifth derivative to get the, by plugging in 5, negative 1 to the 5, 5 minus 1 factorial, 2 to the 5 if we wanted. Okay, so write the first four non-zero terms in the general term of the Taylor series for f around x equals 1. Okay, we know that. We know that the nth degree term is the nth derivative of f divided by n factorial multiplied by x minus 1 to the n. So it's going to be f of 1 plus f prime of 1 times x minus 1 to the first, f double prime of 1 divided by 2 factorial, x minus 1 to the 2. We want the first four non-zero terms. That's going to be 3. Here's the fourth is going to be triple prime at 1 divided by 3 factorial times x minus 1 to the third. Now, it wants the general term, so I'm going to set up for the general term. That's going to be the nth derivative of f at 1 divided by n factorial times x minus 1 to the n. Okay. Well, we're basically just going to plug in on f of 1, f prime of 1, f double prime, starting at n equals 2, we can use this formula. So let's do that. F of 1 is 1, f prime is negative a half. Okay, f double prime is going to be negative 1 to the 2 is positive 1. 2 minus 1 is 1 factorial over 2 to the 2 is 4. So plus 1 over 4 x minus 1 to the 2. Okay, f triple prime is going to be negative 1 to the 3 is negative 1, so I was probably a little early with that. I've waited. Minus. Okay, 3 minus 1 is 2 factorial over, and I'm just going to start writing 2 to the 3. Okay. And, oh, what have I done? I have not divided by 2 factorial and 3 factorial. I bet they got a lot of people with that one. Times x minus 1 to the 3. All the way up to the nth derivative of f at 1 is, well, negative 1 to the n minus 1 factorial over 2 to the n, and divided by that n factorial. Now, we could kind of like cancel some stuff off here, but we don't need to, especially if we're thinking about free response. My recommendation is that you not, right? Because I don't want you to go off and, say something like this cancels off and just leaves me with 1 n minus 1 in the top. That would be not right. Okay, you would have 1 n left in the denominator. N minus x minus 1 to the n. Okay, so that's what they wanted us to do. Just the first four non-zero terms in the general term of the Taylor series for f around x equals 1. All right, next they're going to ask me about the interval of convergence. And, oh, I like this type of problem. They're going to tell you, the radius is 2, find me the interval. Okay, so that saves us kind of that ratio test step. Okay, so what we're going to do is we're going to go over here, and I'm going to say, well, it's centered at x equals 1. Okay, so the radius is 2 means that kind of the endpoints are going to be 3 and negative 1. So I need to test the endpoints for convergence and to determine the actual interval. Okay. So the interior, I don't know why I moved that, the interior is going to be negative 1 to 3. So let's just test the endpoints, x equals negative 1. When x equals negative 1, well, I'm going to have to go over to my, general formula, which, okay, I realize I've kind of messed this up on the sheet of paper, but it's the sum of negative 1 to the n. Okay, after simplifying, I had an n times 2 to the n in the denominator. I canceled off some factorials. And I also had an x minus 1 to the n. Well, x minus 1 is going to be negative 2 to the n, which is going to be, okay, I'm going to go over here, and I'm going to start canceling some stuff. Okay, so I have negative 1 to the n, and another negative 1 to the n is negative 1 to the 2n is always going to be positive 1. And then the 2 to the n's are going to cancel. So I've got basically negative 1 to the 2n times 2 to the n over 2 to the n divided by n. Well, after a little more analysis, I realized, okay, that's going to be gone. This is always going to be 1. This is the harmonic series, 1 over n, just disguised. So I'm going to say the harmonic series diverges. And then at x equals 3, reasonably, I've done enough of these to know I bet this one's going to come back to be the alternating harmonic, but I need to do a little analysis. So I'm going to have negative 1 to the n divided by n times 2 to the n. And I am going to have, it's x minus 1 to the n. So it's 3 minus 1 to the n. So I've got that. Yes, this is the alternating harmonic series. It converges. And I always like these because we don't have to go and give any more reason. We don't have to run the p-series test, or even worse, the limit comparison test. The limit comparison test is great for just knowing if a series is going to converge or diverge, but it is kind of, lengthy to write out all the stuff. So since it diverged at x equals negative 1 and converged at x equals 3, I'm going to say negative 1 is less than x, which is less than or possibly equal to 3. All right, now I'm going to scroll this down a little bit, and all right, now that kind of messed it up, but it'll be all right. The Maclaurin series for f is given below and converges for some values of x that are inside the radius of convergence. And we're going to need to find the radius of convergence using the ratio test. We can do this. Okay, so what I'm going to do is I'm going to start off with the ratio test. Remember, they always start off with sets up limit of ratio. So I'm going to do that. an plus 1 divided by an. I've set up the limit of the ratio. Okay, an plus 1, I'm just going to replace plus 1 wherever I see it. So it's going to be negative 3 to the n divided by n plus 1 with an x to the n plus 1 in the numerator, divided by the original, so that'll be an n divided by negative 3 to the n minus 1 times x to the n. All right, so really what I'm going to be left with is this limit as n goes to infinity of, okay, I'm going to keep the n's off to the right, so I'll have an n divided by n plus 1. Which I know is going to eventually go to 1 as n goes to infinity. And then I'm going to cancel off, okay, all but one of the powers of x are going to go. So I'll have an x in the numerator. And all but one of these powers of negative 3 are going to go. So I'll be left with 1 negative 3. So I'll have x times negative 3. This is probably not how I would write it. I just kind of got myself jammed up there. And as n goes to infinity, what's going to happen is it's going to be the absolute value of negative 3x, which is going to be the same as the absolute value of 3x. And that means that if I set this, less than 1, I could divide both sides by 3. That's not going to really affect the nature of the absolute value or the inequality or anything. And that would be absolute value of x is less than 1/3, meaning the radius r is 1/3. Okay. Write the first 4 non-zero terms in the Maclaurin series for f prime of x. Oh, I would love to do that. Okay. That is, that's the best kind of question for us. And I'm just having major problems here. Because what we're going to do is we're just going to take the derivative term by term. F is a polynomial. So it's represented by a polynomial, and we know how to take the derivative of a polynomial. First 4 non-zero terms. All right, well, f prime of x is going to be equal to 1. Okay, I bring that 2 down. I'm going to have 6 divided by 2 is 3, minus 3x, plus 9x squared, and all the way down to, okay, well, what will the next term be? Well, I'm going to go over here, and I'm going to just kind of try to fit in here, or maybe I'll just kind of draw an arrow and I'll say the next one would be minus, okay, this is going to be where n is equal to 4. Okay, so I've got negative 3 to the 3 is negative 27 over 4 times x to the 4. Okay. When I take the derivative of this, I'm going to have negative 27x to the 4. No, negative 27x to the 3. I need to bring the 4 down and reduce it by 1. So minus 27x to the 3. And it does seem like it's fitting some sort of pattern. So I have a feeling they're going to be asking about, this is a geometric series, they're going to ask about, what it converges to or something. Hey, that's the first 4 terms in the Maclaurin series for f prime of x. So I might put a ... to indicate that I know what's going on, but they are only asking for the 4 terms. That's all they're looking for. Okay. Part C, let's see, do I have it under here? No, I don't. The other pages of this homework. Here it is. All right, what I'm going to do is I'm going to go over here, and yeah, the Maclaurin series for f prime of x is geometric. Write an explicit equation for f prime of x where x is within the radius of convergence. Okay, well, remember that the sum is equal to the first term times 1 over 1 minus the common ratio. Okay, well, the common ratio in this case is going to be negative 3x, and the first term is 1. So it's 1 over 1 minus negative 3x. All right, now they want us to write the first 4 non-zero terms of the Maclaurin series for e to the x. Okay, so this, I know exactly what this is going to entail. We're going to start off with writing down our known Maclaurin formula for e to the x. And e to the x, f of x, is going to require that I just have that series there. Okay. So e to the x is equal to 1 plus x squared over 2 factorial plus x to the 3 over 3 factorial. First 4 non-zero terms, so I'll say plus ... Okay, then if I want the third degree Taylor polynomial for e to the x multiplied by f of x, that's going to be 1 plus x squared over 2 plus x to the 3 over 6 times f of x is x minus 3 halves x squared plus 3x to the third, and so on. Well, if I want the third degree polynomial, I'm actually not going to need even this term, because anytime I distribute this onto the terms of f, this is the degree is gonna grow bigger than 3. So I'm gonna just need these 3 multiplied by those 3, and I'll be able to get the Maclaurin series for e to the x f of x. This is the one where I like to set it up using a box. Okay, so I'm going to do that. I'm gonna say 1 plus x squared over 2. I'm going to multiply this by x minus 3 halves x squared and positive 3x to the third. Okay. I'll do this column first because it's just multiplying by 1. Okay, when I multiply by x, I'll have an x squared, a negative 3 halves x to the third, and a 3x to the 4, which I don't care about because I only want the third degree, so I probably am not going to even need this spot or that spot either. Okay, so x, yeah, it's going to be x to the 3 over 2. This is going to be an x to the 4th level term, and then that'll be an x to the 5th level term that I also don't need. And now I'm just going to, collect stuff. I've got looks like I have no constant term. I'll have g of x's Maclaurin series is going to be x plus an x, and minus 1.5 is, I think, going to be minus 1/2 x squared. Then I'm going to add a half, minus 3 halves is going to be minus 1, plus 3 is positive 2. And that's the first 3 non-zero terms. Or, no, yeah. So it's the third degree Maclaurin polynomial, is this stuff here. Right. Okay, next they're going to talk to us about this function f having derivatives of all orders. And, okay, so they're going to ask us about specific Taylor polynomials, kind of what this means. So it's known that f of 0 is negative 4, and p1 at 1/2 is negative 3. And they want us to show that f prime of 0 equals 2. This one's very strange. What I'm going to do is I'm going to say, well, p1 is the first degree Taylor polynomial, also known as the tangent line. So p1 of x is going to be f of 0 plus f prime of 0 multiplied by x. Okay, so it's going to be f of 0 is negative 4, so negative 4 plus f prime of 0 multiplied by x equals 1/2 gives us negative 3, right? Because p1 at 1/2 is negative 3, and I get that by plugging in 1/2 for x. So I'm going to add 4. So I've got 1 is equal to 1/2 of f prime of 0, indicating to me that f prime of 0 is 2. Okay. So if you just knew where to start, this one wasn't so bad. But if you didn't, I could see this one being pretty tricky. Okay. It's known that f double prime is negative 2/3 and f triple prime is 1/3, and they want us to write the third degree Maclaurin polynomial. That's going to be pretty straightforward. Okay, because I know that the third degree is going to be f of 0 plus f prime of 0x, f double prime of 0 divided by 2 factorial x squared, and f triple prime of 0 divided by 3 factorial x to the 3. I already know all these things, right, because I just found out that f prime of 0 is 2, so I've got negative 4 plus 2x, f double prime is negative 2/3, so plus negative 2/3 divided by 2 factorial x squared, and f triple prime divided by 3 factorial is going to be 1/3 divided by 3 factorial x to the 3. Okay. All right, next we're going to talk about this other function. H has derivative given by h prime is f of 2x, and h of 0 is 7. All right, so what we're going to need to do is we're going to need to go from f of 2x. We want the third degree. So I'm going to say that third degree Taylor polynomial for f of 2x is going to be negative 4 plus 2 times 2x is going to be 4x. Okay, this ends up being negative 1/3 minus 1/3 of 2x squared to be 4x squared. And then if I take 2x and cube it, I'm going to have 8x to the thirds, and that's 3 times 6 is 18. So 8 on 18 is 4 over 9. Okay, all just by plugging in 2x here, here, and there. Okay, then I'm going to say, well, h is the antiderivative of f of 2x. It's going to be, there's going to be a plus c. There's going to be a negative 4x. And then from there, I'm just going to go in. Plus 4/2 of x squared, right? Increase the power by 1, divided by the new power, minus 4 over 9 x to the 3, and then plus 1 over 9 x to the 4. Okay, well, I only want the third degree Taylor polynomial, so I'm going to not give them anything they didn't ask for. And to find this plus c, well, h of 0 is equal to 7. Okay, so when I plug in 0, 7 is going to be 0 plus 0 plus 0, and a bunch of zeros plus c, so that's going to be c equals 7. So the third degree Taylor polynomial for h is going to be 7 minus 4x plus 2x squared minus 4/9 of x to the 3. All right, the function g has derivatives of all orders, and the Maclaurin series for g is given. Use the ratio test. Okay, we can do that. We should be able to edit this by now. So I'm going to set up the limit of the ratio. so when I plug in an plus 1, okay, the negative 1s are going to go away, so I'm not even going to deal with that. X to the 2n plus 3, because I put in n plus 1 here, I get 2n plus 2 plus another 1, over, and maybe I'll show you how that ends up going. Right, and that's why it ends up being 2n plus 2 plus 3 more is 2n plus 5. Times the reciprocal of the original, 2n plus 3 divided by x to the 2n plus 1. Okay, this is going to become... All right, this is 2n plus 5, 2n plus 3. I'm going to kind of hold those off. This limit's going to come back 1 as n goes to infinity. They're essentially the same. And then I'll have x to the 2n plus 3. Well, that's like x to the 2n plus 1. And then 2 more powers of x. Get rid of these. And this is going to be the absolute value of x squared. Okay. Well, I need that to be less than 1 in order for this thing to converge absolutely. So that's just where x is between negative 1 and 1, if you think about it. And then I'm going to consider the endpoints. At x equals negative 1, I'm going to have the sum of negative 1 to the n times negative 1 to the 2n plus 1 divided by 2n plus 3. Okay. Well, what's happening here? This is alternating back and forth. Negative 1, 1, negative 1, negative 1, 1. Oh, I said that wrong. So this one is always, this isn't always an odd number, 2n plus 1, meaning that negative 1 to an odd power is always negative 1. So this is not going to alternate. So I guess really what I have is the kind of, you could say this is negative 1 to the n over negative 3 minus 2n or something. It's just a negative series that's much like the harmonic series. Unfortunately, I am going to have to run limit comparison on this one. Okay, so I'm going to have to look at the scoring guidelines for this one and see like how they were scoring it. I'm going to actually pause the recording of this video and come back with that in a second. Okay, they had a good idea. I'm going to steal their idea. So, you could run through and you could do limit comparison test, or maybe you're sitting there at home being like, dude, what are you thinking? Why are you not just writing out the terms of the series and analyzing it? Okay, so that's what I'm going to do. And so that's going to end up being, when x is negative 1, I have negative 1/3 minus negative 1 over 5 is plus 1 over 5, plus negative 1 to the 5th is negative 1 minus 1/7 plus, okay, the next term would be positive 1/9, and so on. This converges by the alternating series test. Okay, and that's pretty nice. Okay, so it converges by the alternating series test. The terms are decreasing in size. They're going towards 0. I'm happy. And now, if this was my free response on my AP exam, I'm checking the conditions here. I do not. They're just saying it converges by the alternating series test. My understanding is that you have to check that, but I'm, in the interest of space and time, I'm going to not do that. And then at x equals 1, what I'm going to do, I'm going to do the same thing because it worked out so well for me the last time, just writing out the terms. I'm going to say 1/3 minus 1/5 plus 1/7 minus 1/9, and so on. Bless you. And I think it's the same thing, converges by the alternating series test. I think that, on a test or an exam or whatever, I would check the conditions of the alternating series test for the terms are decreasing in size. They're headed towards 0. But, for this homework, I think they are right there. Write the first 3 terms in the general term of the Maclaurin series for g prime of x. Oh, I would love to do that. Okay, so the first 3 non-zero terms is going to be x over 3 is 1/3 minus 3/5 of x squared plus 5/7 of x to the 4. And the general term, what I'm going to do is I'm going to try to just take the derivative of this. Okay, so what's going to happen is this doesn't care, this is just a number with respect to x. So, I'm going to leave that as it is, bring down the new power. So negative 1 to the n times 2n plus 1, x to the 2n plus 1 minus 1, because I took the derivative, reducing the power by 1. And I'm still dividing by 2n plus 3. So really what I should see is power, one number bigger, three numbers bigger. Power, one number bigger, three numbers bigger. Same thing everywhere. Power is 1, or I guess no, power is 0 here. There's no x, meaning that I'm going to see bigger by 1, bigger by 3. It works. All right. All right, next we've got this one. I think I remember this problem. The function f has derivatives of all orders. Let g be the integral of f from 0 to x, and then add 1. Okay, so I'm not really sure what that's going to do, but I have a feeling that'll help us with a constant term or a plus c or something. So write the first three terms in the general term for cosine x. Okay, that's always good. We know how to do that. Is the even one. So start off with 1, negative x squared over 2 factorial, x to the 4 over 4 factorial. That's three non-zero terms. The general term is negative 1 to the n, x to the 2n, all even numbers, 2n factorial. Use this one to write the first three non-zero terms in the general term for f. Okay, so f is cosine of x minus 1 divided by x squared, except for where x equals 0. So remember that f's Maclaurin series is going to be, well, f of 0, negative 1/2, plus, okay, and then I've just lost 1 and then divided by x squared. So I'm going to have, oh, that's interesting. Okay, I got too ahead of myself using that negative 1/2. What I'm going to do is I'm going to kind of do this step by step. It's going to eventually, I'm going to subtract 1 first, which is going to kill that off. So I'll have negative x squared over 2 factorial plus x to the 4 over 4 factorial. Okay, the next one would be minus x to the 6 over 6 factorial, and so on up to the general term. Yeah, I see what I'm going to do. Negative 1 to the n, x to the 2n divided by 2n factorial. Okay, that's cosine of x minus 1. Then I'm going to go in and I'm going to divide everything by x squared. So I'm going to multiply by 1 over x squared. And so that ends up with me getting a negative 1/2, which is what they were telling me over here, plus x to the 2 over 4 factorial minus x to the 6 over 4 factorial, all the way up to negative 1 to the n divided by 2n factorial x to the 2n, and then I divide it by x squared. And if you want to simplify that, be my guest, but I'm going to just leave it like that to really just show that I divided each term by x squared. You can call this x to the 2n minus 2, right? I probably will on the answer sheet. And then part B. Okay, use that Taylor series to determine if there's a maximum, minimum, or a neither at the point where x equals 0. Okay, well that would be something we can definitely do. What I'm going to do is I'm going to go over here, and I'm going to say because there is no x term, so f prime of 0 divided by 1 factorial times x to the 1 equals no x to the 1s, which means that f prime of 0 equals 0. Now, since over here my second degree term is x to the 2 over 4 factorial is going to be f double prime of 0 divided by 2 factorial x to the 2. Basically means, I could solve for f double prime, or I could say that f double prime of 0 is positive. So if it's flat while smiling, flat and smiling, I'm at a relative minimum. And then write the fifth degree Taylor polynomial for g around x equals 0. I think there was a fourth part of this, I just didn't like it as much. Yeah, there was part D, I just don't remember what it was. Okay, so g is 1 plus the integral from 0 to x of f of t. Well, I think what I'm going to do is I'm going to just leave kind of a spot for that 1. I'm going to actually slide this paper up underneath. Whoops. And I'm just going to adjust this. Okay, so I'm going to start by anti-differentiating f. G's fifth is going to be negative 1/2 x. Increase the power by 1, divide by the new power. I've done this wrong. Hold on a second, because it says 5th degree, so I'm going to want to stop at x to the 5, but I've got an x to the 6 over here. Oh, okay, I see what it is. I didn't divide by 2, like 2 powers of x over here, so that's going to be an x to the 4. Yeah, you'll have to excuse that. That was pretty bad. Remember, I was dividing everything by x squared, I divided by that by x squared, I divided by that by x squared, but I did not divide x to the 6 by x squared. Okay, so that's where I'm seeing it. Okay, so I'm going to anti-differentiate, and I'm going to get x to the 5 over 5 times 4 factorial, and that's going to be most of it, except for the fact that you can see that g of 0 is equal to 1, because g of 0 is 1 plus the integral from 0 to 0. So it's going to be 1 minus 1/2 x and all of this stuff. Okay. Next, I'm going to look at 08, form B, number 6. Okay, write the first 4 non-zero terms in the general term of the Taylor series for f around x equals 0. Now what I'm going to do is I'm going to start with 1 over 1 minus x, and I'm going to build up from there. So 1 over 1 minus x is equal to 1 plus x squared plus x to the 3 all the way up to the general term as x to the n, meaning that 1 over 1 plus x squared, I'm going to replace x with negative x squared. And I'll probably eventually write that as negative 1 to the n, x to the 2n, but maybe not yet. So 2x over 1 plus x squared is going to be, I'm just going to distribute in a 2x to everything. 2x minus 2x to the 3 plus 2x to the 5 minus 2x to the 7. That's the first 4 non-zero terms. The general term will be, actually, you know what, I'm probably going to leave it like that. Now on the answer key, you know I'm going to be simplifying that, but that's certainly a safe place to stop. Okay, does the series found in part A, when evaluated at x equals 1, converge to f of 1? Explain why or why not. Well, what is f of 1 going to be? That's going to be the first question. Pretty much the only ones of these that we know how to evaluate are geometric series sine and cosine and e to the x, more or less. And so, you know, I assume that this is looking at being geometric because each time I'm multiplying by negative x squared. So, and if x is 1, I'm not really feeling like that's going to be a convergent geometric series, but we'll find out. Okay, so first things first, I'm going to find that f of 1 is equal to 2 over 2, which is 1. Okay. The Maclaurin series for f around x equals 0 applied at x equals 1 could be represented by 2 minus 2 plus 2 minus 2. I see what's going on. And this does not converge. This one diverges by the nth term test. These terms aren't going towards 0. Which means that, you know, the limit as n approaches infinity of, you know, 2 times negative 1 to the n, which is basically what these terms are. Maybe n plus 1. Depending on if we're starting, it didn't say where we're starting, but this limit does not exist because of oscillation. And so that, therefore, it diverges. No, it does not converge to f of 1. Okay. The derivative of log of 1 plus x squared is f, right? The first 4 non-zero terms of the Maclaurin series for log of 1 plus x squared. So what I'm going to do is I'm going to say, well, if the derivative of log of 1 plus x squared is that, then log of 1 plus x squared is the antiderivative of that. Okay, so I'm going to say that log of 1 plus x squared is going to be equal to the antiderivative of this. So antiderivative of 2x is going to be x squared minus 2/4 x to the 4, first 4 non-zero terms, plus 2/6 x to the 6th, minus 2/8 x to the 7. And I'll just indicate that I understand that's going to continue going on that pattern, but that's just all they asked for, first 4 non-zero terms. Hello. Okay, realizing I did not increase the power by 1. I think I said it out loud, 2/8 x to the 8th, but I wrote it as x to the 7th. Okay, so that's that. Over here recording my answers in my Word document. Now I got one more page. Let's see, where are we? All right, find the first 4 non-zero terms in the general term for f around x equals 0. Okay, this is another one. We're going to start with Maclaurin series and build up from there. Okay, so I'm going to say e to the x is equal to 1 plus x squared over 2 factorial, x to the 3 over 3 factorial, up to the general term is x to the n over n factorial. E to the negative 3x is, I'm just going to replace x with negative 3x. Okay, since I know what 3 to the third is, I'm going to actually do that. Wait, but I'm replacing it with negative 3, so negative 3 to the third is negative 27. And that's negative 3x to the n over n factorial. So 6e to the negative 3x is equal to 6 minus 18x. Okay, when I multiply by 6 and divide by 2, that's like multiplying by 3, so plus 27x to the 3. When I distribute in the 6, so that'll kill that off. Is that right? Okay. That was an x to the 2. Okay, it was a little rough making some errors here. Let's see. I guess because of the way that x is increasing and, or, you know, the powers of 3 and n factorial, that would be the same. I'm going to check that before I, you know, move on too far. Plus dot 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 plus 6 times negative 3x to the n over n factorial. All right, looks like when I was copying this problem, I copied it wrong. It was supposed to be negative x divided by 3 in the actual 2007 Form B. I do think I'm going to just stick with this since I've already printed these homeworks. What I'm going to do is I'm going to just, I guess, double check. 1, negative 3x plus 9x squared minus 27x to the third. I'm good with this. So when I distribute in a 6, I'm going to have 6 minus 18. So 6 times 9 is 54 divided by 2 is 27. And then, well, just so I'm not, you know, putting the wrong answer on the internet, I'm going to double check my arithmetic. I'm getting a calculator out. I'm going to do 27 times 6 divided by 3 factorial is divided by 6. I know that's going to be 27. Okay, that's fine. And I'll stop right there. Okay, let g be the function given by 0 to x of f of t dt. Find the first 4 non-zero terms in the general term of Taylor series for g around x equals 0. Well, the first thing I'm going to say is g of 0 is 0. So it's going to be an antiderivative, so it's going to be c plus 6x, but c is going to be 0. So it's going to be 6x minus 9x squared plus 9x to the third. That's, okay, x squared divided by 2, x to the 3 divided by 3, it's just coincidence. Minus 27 over 4, x to the 4. First 4 non-zero terms, general term, plus 6 times negative 3x to the n plus first power, divide by the new power. Okay, and there we have it. Okay, and then I think I'm just going to finish this off and update my answers sheet after I'm done with everything. So, find the interval of the convergence for the power series for f. I'm going to do the ratio test. Since I've done this a couple times, I'm going to do this pretty quick. That's the limit as n goes to infinity of a n plus 1 is going to be, okay, not going to include the negative 1 to the n. That'll be n plus 1, x to the n plus 1, divided by n plus 1 plus 1, divided by the original is n plus 1 divided by n x to the n. Okay, g is this other thing. Oh, we're going to use g down here. I was like, why did I even bring that in? Okay, so that's going to be the limit as n goes to infinity. I have all but 1 power of x canceling, multiplied by the stuff with n's. That's going to be n plus 1 squared divided by n squared plus 2n. These are both going to be second degree with leading coefficient 1, so that limit will be 1. That's going to be equal to the absolute value of x, which needs to be less than 1. That means that the interior of the interval is negative 1 to 1. I'm going to check the endpoints. At x equals negative 1, I have the sum of negative 1 to the n times n times negative 1 to the n divided by n plus 1. This is certainly diverging by the nth term test. Because it's the same on top and bottom. This one's interesting. I don't know that I've done this problem before. Okay, and then at x equals 1, I feel like I'm going to see the same thing. I don't really think there's any saving the fact that there's an n on top and an n on the bottom. Is that really what happens? Yep, sure enough. One thing I am going to point out is that if x is less than 1 in absolute value, we do end up with something that's like pretty geometric or exponential. In the case, it's going to really outweigh this thing going to 1. So it will be all right if x is between negative 1 and 1. So x equals 1, I have the sum of negative 1 to the n times 1 to the n is just 1, so times n over n plus 1. That is alternating, and I do believe that, now I think these terms are actually increasing in value, like they're getting closer and closer to 1 from the underside. I'm not sure about that. Let's just check. 5 divided by 6, 6 divided by 7, 7 divided by 8, 8 divided by 9, 9 divided by 10. You can see that these are actually getting bigger. Okay. So the terms are not decreasing. They are not going to 0. This thing certainly diverges. Okay. That was interesting. So my interval is just that negative 1 to 1, not including negative 1 or 1. Okay, h is some function defined by f minus g, passes through the point 0, negative 1, find h prime of 0 and h double prime of 0. Well, that means that h prime of 0 is going to be f prime of 0 minus g prime of 0, and I should just be able to plug these out from the equations for f and g. Okay, it's going to be the number that's attached to the linear term. All right, it's the linear term's coefficient, whatever you want to say. So f prime of 0 is negative 1/2 minus g prime of 0 is also negative 1/2. So that good chance of it being a local maximum or local minimum, especially given the fact that we only really have information about this function at x equals 0. H double prime of 0 is going to be f double prime of 0 minus g double prime of 0. Okay, f double prime is going to be, well, this is going to take a little more work, and I'm going to need more paper. So I'm going to bring in a scratch sheet of paper. Well, that's tough. I'm going to grab 2/3 for f. 2/3 is the coefficient of x squared. So for f double prime of 0 divided by 2 factorial x to the 2 is going to be 2/3 x to the 2. Meaning that f double prime of 0 is equal to 4 divided by 3. G double prime of 0 divided by 2 factorial x to the 2 is, I go back up here to g, and that's 1 over 4 factorial is, I think, 1 over 24. Okay, meaning that g double prime of 0 is equal to 2 divided by 24 is 1/12. So if I take f double prime and I subtract g double prime, this is certainly going to be positive. And since I have a zeroed out first derivative, it's flat. Since the second derivative is positive, it's smiling again. Okay, that means it's a relative minimum. So I said local minimum. And that's all for this homework.